Okay, welcome everybody to Not at the Museum Thursday night. As usual, I'd like to begin our program with a land acknowledgement. Niagara region of Ontario is located on the traditional shared territory of the Anishinaabe, Haudenosaunee, and Chinootan peoples. The Chinootan people have called these lands home for thousands of years, and more recently, the Anishinaabe and Haudenosaunee have been sharing this land as one dish, one spoon treaty territory. Each night, the stars reveal the entire universe. The ancients described them by the myriad of myths of the gods and placed them in the sky to remind us of our mortal limitations. Too few people spend a moment to look up, but with COVID restrictions, people are looking for new interests in their own backyards. What better time to begin our understanding of the night sky? Tonight, we welcome Dr. Brian Pihack from Niagara Centre of Astronomy. He'll take you on an extraordinary tour of the heavens over 2 presentations tonight and next week. Before I welcome Dr. Pihack to begin his presentation, a bit of housekeeping. Following this presentation, we'll be open for questions. And if you're joining us in Zoom, you can type your questions into the Q&A function. If you're joining us on Facebook Live, just add your questions to the comment section and I'll do my best to monitor them. Dr. Brian G. Pihack, BC, is a local chiropractor, the past president of the Niagara Centre of Astronomy, and retired national representative to the Royal Astronomical Society of Canada. Dr. Pihack received his first telescope at the age of 12, and it's been a way of life ever since. Take it away, Dr. Pihack.
Well, good evening, everyone. And yes, we will keep about 15 minutes near the end of the talk to answer any kind of questions that you have. If you have any questions that are very complicated, then what we can do is I will defer them till next week when we do another session. And and I just disappeared.
Oh, we can hear you. We just can't see your screen.
That's interesting because the whole thing just died on me here. Let's see if we can bring it back. This happened when you first started going on the internet. Okay.
Oh, there you go. You're back.
I'm back, so you can hear me as well?
Yes, all go.
Oh, no?
No, it's good. It's good. You're on.
We're on, okay. Okay, so we're gonna do a little bit of basic astronomy, something that you can simply go out your back door and start to look in the sky and take a look what's going on. We'll do a little bit about what's been in the news with astronomy as well. And anytime you go out into the dark, we call them red light specials because any flashlight you have should be covered with a bit of red cellophane so that it doesn't wreck your dark sky adaptation that your eyes undergo. It takes about 15 to 30 minutes for your eyes to become accustomed to the dark. So any type of chart book that you take out, always bring a red flashlight so that you don't ruin that adaptation. Now this time of year, we have a very interesting situation going on with the moon. If you look at the picture, you can see that part of the edge on the right side, the bright crescent is fairly bright, and yet you can still see some of the dark side of the moon, and pardon the pun. And this typically happens around now when we have a certain arrangement. The sun will bounce light off of the part of the moon closest to the sun, and then that bounces off to us here on Earth, and we see part of the crescent moon. What also happens is that the sunlight will bounce off of the Earth's upper atmosphere, part of the tops of the clouds, and then it'll bounce towards the moon. It will illuminate the part of the moon that normally we shouldn't be able to see. And then of course that light comes back to us and we can see the dim part of the moon. It's often called the old moon in the arms of the new, or vice versa, depending on what part of the phases the moon is in. Now on the full moon of April, it's going to be called the pink moon, not because it's going to turn pink, although I'm sure that'll probably get put on the social media, but because of the pink flowers that apparently come up at this time of year. And there's also something else about the moon that we'll talk about in just a moment. Now, even though these are nice pictures, these are most definitely not to scale. And when we bring the solar telescopes out, or the telescopes specifically designed to look at the sun, most people are amazed at the fact that the sun appears so big. In fact, it's very, very big compared to us. Now, here's an actual picture of the sun, and you can see the picture of the Earth that we put in right there. On average, we can put about 1,300,000 Earths in the volume of the sun. So the planet that you're walking on that takes, 22, 24 hours to get to the other side by aircraft, you need 1,300,000 of them just to fit into the volume of the sun. Now, this is a picture of the sun when it's very, very active. Every 11 years, it goes through a complete cycle of sort of becoming somewhat quiet, and then it starts to come back to life, and we end up with these very, very big filaments, these prominences and flares. And these are the ones that are going to cause a little bit of havoc for us later on, but we'll discuss that in just a moment. Here's another representation. This is an actual picture taken by one of our members of the sun through our solar telescope, and put a picture of the Earth there. Again, just to show you how really small we are, how really big the sun is. And we'll even talk about some of the other stars, showing you that even the sun itself in this size isn't really that big comparatively. Here we have the sun in the background, and of course the planets in the foreground, and here we are with the Earth and Moon, and you can see the size relationship. Here's the planet Jupiter, the largest of the gaseous planets, and there's a storm, a cyclone happening on Jupiter. We're going to talk a little bit about this guy here, Mars as well, because of course it's in the news with Perseverance. If we take just North America and put it next to this cyclone that's happening on Jupiter, this storm, you can see that we could almost put 2 entire Earths in this one storm in and itself. So when you have a hurricane here on Earth, remember that the ones on Jupiter are literally twice the size of our Earth. Now, if you look off towards the south and west as the sun starts to set, and somewhere around 10 o'clock, you'll see this constellation here. Now, this is Orion the Hunter, and it's one of the more famous constellations. It almost looks like an hourglass here with the brightest of stars. Now, if you're in a dark sky location, you'll see all of the rest of the background stars, but typically this constellation will stand out quite by itself. We'll be talking about this object right here, which is the Orion Nebula. And this is something that you can see naked eye to look like a fuzzy gossamer blur, but with a pair of binoculars, you'll be able to see it quite nicely. We're going to be talking about this star right here, which was also in the news a little while ago, it of course being the star Beetlejuice. And at the time, they weren't sure if Beetlejuice was going to blow up. It started to look quite a bit different. It looked very, very strange. And there were some people that thought it would blow up, when in fact, not really. It was just some cloud, dust, and debris that got between us and the star. But this is the one star we're going to talk about. We'll talk very briefly about this star. This is Aldebaran. It's in this V shape of stars, part of the Taurus, the Bull constellation. But right now we're going to talk about this star, Cirrus, which is the brightest star in our skies right now. This is the closest star that we can see here in the Northern Hemisphere. And it's still, even though it's close, it's still about 9 light years away. So light literally takes 9 years to get from this star, to us. 9 years ago, Skyfall opened up the theaters as well as did the Hunger Games. So imagine photons of light leaving this star 9 years ago when you were watching Skyfall, and just tonight, tomorrow night, or whenever the sky does clear, you'll see those photons and its journey. Now, I've got a better representation coming along, but we'll put this one in just for the moment. There is the diameter of the sun, and you remember how tiny we are compared to the sun. Well, here is the sun compared to the diameter of Betelgeuse itself. Okay, that's this star right here. If you look at it, you'll see it as a dusky red star. This one over here is Rigel, which is this blue star here, again, much, much larger than the Earth. And this one over here, Aldebaran, the eye of the bull constellation Taurus, is as well still very much larger than the sun. So there are some very large stars out there. When they get to be big, red, and swollen like this, they are in their last throngs of life, and they will burst into the largest explosion in the galaxy called a supernova. Here's a better representation of how big Betelgeuse would be compared to the sun. If we took our sun out and dropped Betelgeuse into its place in our solar system, it literally extends all the way out past the orbit of Jupiter. Now, light takes about 8.5 minutes, give or take, to get to the Earth from the sun. From the sun to Jupiter, it takes a beam of light 47.3 minutes. So traveling at 186,000 miles a second, 300,000 kilometers a second, it would still take 47 minutes to get to the orbit of Jupiter. And this star Betelgeuse is much larger than the orbit itself. Now on the 26th, we were talking briefly about the moon. It's also going to be a supermoon. So it's going to be about 30,000 kilometers closer to us. Now the orbit of the moon is a bit of an egg. Will be near and farther to us at different points in time. On the 26th, at the time of the full moon, it's going to be closer than it is on average. So they're calling it a supermoon. Can you really see any difference? Well, it's only about a 7% change, and that's the difference between a 12 and a 12.8 inch slice pizza, held at arm's length. Can you see the difference? No, not really, but it tends to be something the media likes to expound upon, probably because they haven't got very much of anything else to talk about other than the obvious. Now, if you really want to see a large looking moon, it's quite easy. Just simply catch the moon or the sun when it's rising or setting. There is a phenomena that happens in our brains that when you have foreground material and background material, your brain will tend to shift the size of things a little bit. So when you look at the moon as it's just rising and you've got some foreground in front of you, the moon will look much larger. A couple of hours later, when it's getting up overhead, it seems to disappear back down to the proper size. Now this happens quite a bit in a lot of everyday things as well. I went to Port Colborne one time and I was driving down this road and I couldn't believe I watched the mill, which looked like it was at the end of the road, go from a giant mill. As I drove closer, it began to shrink. So I went back and I actually took the picture. And here you can see it looks absolutely huge. And then as the foreground starts to come towards me and disappear, the mill starts to shrink more and more until we get right up to the bend and the mill looks quite a bit smaller. And this is just a way the brain tends to try and justify our environment. And we do talks to the public and we talk about some of these things as well. Once COVID finishes, we'll be able to get back to some more regular scheduled stuff. Here's one last picture. This is taken of Kitt Peak and the moon in the background, showing you how exaggerated this can actually be. This is why sunsets always look so nice, because the sun looks so large on the horizon because of the foreground. Now I put this in because 20 years ago and 30 years ago, we had some interesting effects on the Earth caused by a couple of storms on the sun. Now here we have the sun depicted in its very active state. We have a solar flare here that is exploding off, and it's carrying a phenomenal amount of energy away from the sun, and it's headed towards the Earth. Now when this happens, the energy pushes back our magnetosphere and the lines reconnect back here, and the energy snaps backwards along these lines and comes into our atmosphere at the north and south poles, causing the northern lights. Now, we really haven't had anything this big and strong happen in the last while because the sun has been in its quiescent state, but it's beginning to ramp up. And it's also interesting for the fact that you can't even buy a toaster that doesn't have a computer chip in it. And this type of energy could seriously cause problems for some of these chips. Now I have a movie here from NASA. Whoops, sorry. March 13th, 1989. This is when one of these storms broke off of the sun and came towards the Earth, and it walloped Quebec. Quebec actually was plunged into darkness because of this overpowering the grid and basically destroying it. It took about 90 seconds for this material to get from the sun to the Earth, and because Quebec is at a bit of a disadvantage, whoops, here's the, beg your pardon, I must have mixed up the slides. Anyways, here we have the sun. It's going to have a flare. The energy is going to come off. This is called a coronal mass ejection. We're talking about Mount Everest-sized chunk of high energy plasma and particle materials coming, hitting our magnetosphere, bending back the magnetic lines, reconnecting them, and then they come towards us and cause the northern lights. Now, in 1989, the big problem, or the area of the sun that caused this problem, was this monstrous dark spot here that we see. This is a sunspot. And remember, this spot right here is probably the size of the Earth. The energy that came around the outside of it and then broke off flew towards the Earth and impacted us. Now, by contrast, this is what our sun looks like yesterday or today. It's very, very quiet, nothing like what we see in the background. And I'm missing a couple slides. Hang on, let's go to the next one. We'll do this one. Okay, the energy hit the Earth. Now, typically the Earth is very good at taking this energy and transmitting it through the medium of the soil and dissipating it so it doesn't cause any problems. But Quebec is at a bit of a disadvantage because it is in an area of Precambrian igneous rock, and this rock doesn't really like electrical currents to flow through it, so it resists it very strongly. So all of this energy coming at us in the form of the CME decided to follow the path lines of all of the electrical grid system. And the amount of energy that went through the grid system was strong enough where it literally started to destroy and explode transformers, wiping out switching stations and actually heating up the transmission lines quite nastily. And here's a picture of some of those transformers and the damage. Nowadays, we build our grids to withstand what they call a 1 in 100 geomagnetic event. So we've learned a lot from this, even though it took them several years to get it all back together. And whoop, there we go. My internet is scarce. Okay. So 1 in 100 year geomagnetic events. Now they did some work on this to figure out when this would happen next, and it might surprise you. Now, we'll go to the next slide here. Then in 2001, another sunspot, this one here, hurled another pair of coronal mass ejections. So not one, but two. So if you can imagine ripples on a pond, you've got one ripple going away from a rock, say you drop in the water, then you drop another rock in the water, and another wave catches up to the first one. And if it's in sync, it'll make that wave twice as high. And that's what happened back in 2001. There was an extreme geomagnetic induced electrical current traveling through the Earth, and it caused the phenomenal aurora. They saw them as far south as Mexico. Now, in this particular one, the one wave came in just behind the other wave, but they were at opposite phases. So one was going high, one was going low, and it basically canceled the effect on our electrical grid. And that was very fortunate because it could have been as bad as the one that happened in 1989. Now, if I was to tell you that an asteroid big enough that it will just pass by the Earth, but if it hit the Earth, it would be big enough to send us back to the 18th century, but it's still going to miss us, the media would be all over that. Well, back in 2012, this sunspot released a tremendous amount of energy. And fortunately, it missed the Earth by about a week in our orbit. Had it not, it would have been one of the more powerful storms that ever hit Earth in the past 150 years. Here's an actual picture of the explosion off of the sun. Now this is our sun here, and this is the explosion coming off. And remember how small we are in comparison to the sun. And the explosion narrowly missed the Earth. Now it occurs in several stages. At first there was a flare, and it broke, as you see here. The energy came off towards the Earth in the form of X-rays and ultraviolet radiation. It only takes a matter of minutes to get there, and it will get to Earth, sorry, and it will cause radio blackouts and start messing up our GPS navigation. About a couple hours later, the energetic particles will arrive, and they're moving just slightly slower than light speed. And excuse me, this blast can really mess up our satellites and anything that is electronic here down on Earth. And then when the final wave comes of the CME, which is, as I said, 1 billion ton of magnetized plasma ions that take anywhere from a day or two to get to the Earth from the sun, this will basically knock out anything that you plug into a wall or has a battery. Fortunately, it missed us. The experts did a recovery time of 4 to 10 years experimentally and a cost of trillions of dollars to get us back to square one. Now I'm explaining all of this for two reasons. One, that this all happened 20 and 30 years ago, as well as 10 years ago. I will show you some pictures of auroras from 10 years ago. And the sun is just starting to waken up from its sleep. They analyzed the data, and they basically said the chance of having another storm this severe in the next 10 years is about 12%. But this was done in 2014, and the sun is just now starting to become more active. At the moment, it's gone back to a bit of quiet time. Here's some pictures taken from the Soho showing you that the sun is pretty quiescent right now. But if you'd like to follow the chance of seeing auroras, or if you want to see auroras, I'll give you a couple of links that you can use. Here's the first one that I do recommend. This is called Space Weather, and you simply type space weather into Google and this website will come up. They've got some very interesting stories in the center to entertain you. They will have a chart here that shows you a green band. When the green band starts heading over towards the Great Lakes area, then find yourself a dark sky. And I really like going out to Fireman's Park or to Fort George, and looking north, you can start to see the aurora happen. They will also have a daily picture of the sun, and you can see here that it's very, very quiet, nothing much going on. Then they will give you this number here, which is called a KP index. And right now it's at a 4. In order for us to see auroras, we have to have a peak KP of about 6, and that's coming in through here. If we have a KP of 6, find yourself a dark sky, go out, take a look, and see if you're lucky enough to see auroras. The other link to auroras in space weather, which is right down here, it says real-time aurora. I click on this one and it will pop up all of the pictures taken by people posting them from different parts of the world. And I'll keep an eye and take a look and see if any come up from Canada or in the States, see how far south the aurora is going and judge whether or not I should go out and take a look. This is Aurora Forecast from Alaska. Basically the same thing. When this edge here comes over top of the Great Lakes, you stand a very good chance of seeing the aurora. This is the Canadian one from Montreal. This gives you a nice little chart. When this bar comes up to 6, then here in Niagara Falls, St. Catharines, Welland, we will be able to see the aurora. Anything higher than a 6, then the aurora gets much more intense. Here's one from the University of Alberta, and they can post them somehow if they'd like, and you can track the aurora quite nicely. Just as a little aside, this morning, Edmonton, they were having, where is it, drifting snow, right there. So we should feel pretty lucky out here. The last one I'll give to you is one from the Northern Lights in Churchill, Manitoba. This is a live cam, so you literally can watch the aurora happen in front of you, and like on an evening like tonight when it's cloudy. and you can watch this just from the comforts of your own home. Now, these are some pictures that I took back about 10 years ago from, this was Fireman's Park. And as you can see, this is facing north. You can see quite a bit of the northern lights from a dark sky, and they do look quite impressive. Now, remember, there's the Big Dipper. So north is right here, due north. This is not a sunrise. West is way over here. And you can see the beautiful plumes, and these were quite easily naked eye. These pictures actually I took with my cell phone. And again, from Fireman's Park. This was from Fort George. This is back 1989 when I was still using a film camera. And again, from Fort George. And if you ever see an aurora in front of you, always look up, because there's something called a coronal aurora, and they happen right up over your head. And again, a couple more pictures from Fort George. And again, just to emphasize the size of the sun compared to the Earth, and a little fact that if you wanted to drive to the sun at 70 miles per hour, it would take you 50,000 days or 150 years. And the last picture I'll show you is from a gentleman in Buffalo, Alan Friedman. He'll be coming to our club, or doing, we're not quite sure, in the near future. He takes pictures of the sun like this, and they are obviously quite impressive. Now, our little Earth is a spaceship, even though it's not as big as perhaps you thought. Right now, here in Niagara Falls, we're traveling at 1,250 kilometers per hour towards the west. Beg your pardon, towards the east, and you don't even feel a thing. And it's like a giant merry-go-round. If you look up towards the North Pole, the stars will move in a small circle, and I'll show you some slides of that in a second. If you look out towards the south, you will see the constellations moving by throughout the night. In 1 hour, we have our Big Dipper right here. So in 1 hour of the Earth's traveling 1,250 kilometers per hour towards the east, the Big Dipper will move from here to here. It'll take 24 hours to go once around. As we move around the sun in our orbit, our direction always changes, our direction stays the same, but the way the sunlight hits us changes. In the wintertime, the sunlight comes and bounces off of the Earth like this. We're tilted away in the wintertime, so the shadows are longer and the sunlight is not as strong and it's colder. Even though in the wintertime, we're actually considerably closer to the sun than we are in the summer. But in the summer, the northern hemisphere is tipped towards the sun. The sunlight comes directly on it. The footprint is much smaller and tighter, therefore it's much hotter. And if you're a person that likes to watch sunsets and sunrises, as we travel around the sun, the area where the sun will rise and set will change. So right now we just passed the equinox. As we're moving towards the June solstice, the sun will continuously rise each day a little bit further till here, about 21st, and then it'll start moving back, and of course it'll be back here in the winter solstice, December 21st. And you can see that as the sun has moved south of east, it sits low in the sky at about noon, and then sets over here. In the spring, it's about halfway up to where it is in the summer, where the sun will rise the furthest north of east. It'll get very high in the sky at noon and then set north of west in the horizon, and our shadows become much shorter. Now, if you take a camera and open it up so that it'll take a 6-month exposure, this is the path of the sun across the sky. In the wintertime, it makes a very low arc. In the summertime, it'll make this really nice high arc. The Earth itself travels around the sun at about 130,000 kilometers per hour. So here we are on the Earth traveling in this direction at about 130,000 kilometers per hour. Now in 1 month, it'll make the constellations move about that much, and again in another month, that much again, simply by moving around the sun. Our solar system itself is moving around the center of our Milky Way galaxy. The distance from here to here takes light about 200,000 years to travel. We're doing about 800,000 kilometers per hour in this direction, and it still will take 225 million years to go around the galaxy just once. In fact, when T-Rex was around, the solar system was somewhere around in this place here. Mars, of course, being in the news because of the rover that has landed there, Perseverance. And just an interesting comparison, we have the blue marble, the blue Earth, and we have red sunsets. And on Mars, which is called the red planet, we have blue sunsets. And if you'd like to find out more about that, we can talk about that next week as well. Now looking towards the south and west at about 10 o'clock, we have the constellation here, Orion the Hunter, sort of looks like an hourglass. We have a V-shaped grouping of stars, the head of Taurus the bull, and a dusky red object right here is Mars. So you can go out tonight, well not tonight, when it's clear, take a look at Mars and realize that we have a probe and we have a rover on Mars. The rover itself, this is Curiosity, and this is the Spirit, Opportunity, and Sojourner. You can see the relative size compared to human beings. And Perseverance is just a little bit bigger than Curiosity. And of course, it's going to have a helicopter disembark and be the first aerial views of Mars from just off the surface. Interestingly, if you look at the amount of memory it has, it isn't really that impressive. What is impressive is the fact that the radiation on Mars is really nasty, and the computers have to withstand some pretty horrific radiation at times. And we'll talk about that in just a second with regards to humans. Here's a picture of Mars compared to the Earth. The Grand Canyon on Earth, you really can't see from this distance, but there's the Grand Canyon of Mars, the Valley Marineris. And it's about 3,000 kilometers long compared to our 800. It's 600 kilometers wide compared to our 30 kilometers, and it's 8 kilometers deep compared to 1.8 of the Grand Canyon on Earth. So it really truly is one of the largest Grand Canyons in our solar system. And to put that into perspective, that's the distance from Toronto to Vancouver. It also boasts the largest volcano, which is about the size of France. And here we can see the Goldilocks area for Earth, Venus at temperature of 420 degrees Celsius, and of course Mars at minus 50 degrees Celsius. This is a dust devil on Mars, and Mars has enormous dust devils. We can see the dust devils appearing and disappearing in this image taken by the orbiter. And the dust devil on Mars is about as high as the Himalayan mountains are on Earth. And here's Olympus Mounds, the largest volcano we talked about just a moment ago. And of course, Earth's dust devils and tornadoes are small in comparison. Here's an actual dust devil filmed from the planet Mars. And when Mars has a dust storm, it really has a dust storm. This is back in 2001. It encircled the entire planet, so that any observing was basically fruitless. Here's another picture taken by the Hubble Space Telescope showing you how dusty Mars can really get. And of course, the sunset from Mars. And sort of getting a little shy on time, so we're going to get to this part. I often get asked about the possibility of humans going to Mars. And with the technology that we have, it is impossible for two very important reasons. And I know Elon Musk has got this big thing going and NASA wants to send people to Mars. But the reality is the last probe that went to Mars, during the flight, when they had some spikes of radiation go through, a human being would be exposed to the same amount of radiation as 12 chest films every day, or 3 complete full body CAT scans every day worth of radiation. During the flight, when the spikes dropped off, it was like getting 5 chest films a day or 1 full body CAT scan every 20 days. Okay, on the surface of Mars, every day you spend there, you'd get about 2.8 chest films worth of radiation or 1 full body CAT scan every month. You will not survive that. To complicate matters a little more and to make a certain movie a little more far-fetched, the soil contains calcium perchlorate in a toxicity level that will kill human beings. So realistically, you cannot grow potatoes. Now, if you want to get into some very easy stargazing, this is Heavens Above. You can link on it and it'll give you times for when you can see the International Space Station going right over your heads or to a point where you can actually see it. It will give you the magnitude. Now, magnitude is a strange way of saying brightness. When we talk about a large negative number, this is very, very bright. You could probably see this with a pair of sunglasses on. The dimmest is going to be over the next little while is about a magnitude of -1, and that is still going to be brighter than most of the stars in the sky. And the space station itself will look like a round of stars. The military time for the start is always, or sorry, the time is always a military for the first sighting that you will get. It gives you the altitude. That's the height above the horizon, and 10 degrees easily is about 1 fist held at arm's length. So if you hold your arm out at fist length and show 10 degrees, that's about where the ISS is going to come up off of the northwest horizon. It will also give you the highest point. That'll be the highest point in the sky, the best part to see it. And as I said, it will look like a bright star moving against the background of stars. This is a time exposure of that, so you see the blur of the line itself. And again, this was done with a cell phone. You can also look for the starlight links. This is Elon Musk's answer to giving internet to everybody in the world. For astronomers, it has been a nightmare simply because he has put so many of them up there that this is what it looks like presently. So if you're doing any type of photography or looking, this is what you're going to see. Now this is sped up, those are aircraft. This here is the Starlink satellites reflecting starlight down toward, or sorry, sunlight down towards you. Now this is sped up a fair bit. This is off of YouTube, but you can see how this would wreck some photography work. And another video, there we go. This is a little bit more close to actual time, and several of our members have seen this go on. This is just as the Starlinks have been released, so they're still in their train. They will space out a little bit more. And this will bring us to this video here. If you watch in this area here, you'll see little dots appear and disappear. Now these are geostationary satellites individually lit up by the sun as the Earth, and they move. And what your brain will do is link the dots up the same way it links up still pictures in a movie, giving you a movie presentation. And people have claimed to see UFOs when in fact this is what they're seeing. If you want to talk about UFOs, then send a couple of emails off to the museum, and I'll do that next week. But on to some actual astronomy. This is a picture, of course, of the Big Dipper. And this is done with a time exposure, so you see far much more in the way of stars than you would normally. This is our Dipper right here. And if you want a test to see how well you can see, you look at the stars here in the little bend of the handle, and they are Mizar and Alcor. If you've got a good pair of eyes or eyeglasses, you should be able to see 2 distinct little stars. If you see just a blur, then it's time to go visit the optometrist. Now this is looking towards the north, of course. This is about 9 or 10 o'clock in the evening, give or take. We have our Big Dipper here, which is at this point in time upside down, dumping all of its contents on the Earth. The natives believed that this was how the Earth was nourished, and we ended up with growth in the springtime. And we have the Little Dipper here. Let me highlight them for you. There's the Big Dipper, part of Ursa Major. And if you take the two stars in the bowl in a straight line and go down to this one star all by itself, this is Polaris, the North Star. It's in the handle of the Little Dipper. And as you can see, it's not the brightest star in the sky. However, it is true north as far as that goes. Here is Draco the Dragon, left over from ancient myths. And we have a W, a letter E, or a letter M, depending on which way you're looking at it. This is Cassiopeia, and again from the ancient myths. And right above her we have Perseus, the bright star here being Mirfac. So we have Ursa Major, the Large Dipper, the Small Dipper you can find by going straight through to this star here. We have the tail of the dragon between the two dippers, and then we have Cassiopeia, fairly easy to spot as the letter M3 or the letter E, and Perseus here. And this is all towards the north and northwest. Looking towards the southwest, excuse me, we have our constellation we talked about before, Orion, and we have Taurus the bull over here, and there was Mars, of course. We have bright star pointing in a straight line towards this star. This is Cirrus. We talked about this one just a moment ago, and it's in the constellation Canis Major. And if we have a large dog, Canis Major, we have a small dog, Canis Minor. And here's just a little darker representation of Orion itself. And we're going to look briefly at this point right here, which is the Orion Nebula. This was taken by one of our members. This is the Orion Nebula. And we're going to look deep in here in just a couple of seconds. There are four really bright stars called the trapezoid. And of course, this is done with the Hubble Space Telescope. But around here, Hubble has been searching for solar systems. And it's found somewhere around the order of about 150 of these little objects here. And I've got some close-ups coming. These are all solar systems just starting to form, and they are all solar systems very much like our own. Here's one that's virtually the same size. After looking at the data for a period of time, they've identified young stars and material around the outside, accretion disks, that are going to start forming solar systems. And in total, they have found more than 150 solar systems starting to form. So in future time, each of these stars will become stars very much like our own, and planets will form around. And let's go to the next picture. Here we go. This was a picture again taken by one of our members, and you can see this without the color. So if you imagine this all in blue, gray, green, you can start to see this in a pair of binoculars, and in a small telescope it will look quite impressive. Naked eye, it's going to look very much like this. This is Beetlejuice, that very large star we talked about earlier. And there is Orion's Nebula, you can see with a pair of binoculars, and there's that hourglass shape here. There's all of the proper stars. And when you look at the constellation, just remember the size of our sun. Okay, there is sun. There are the rest of the stars in the outside of Orion. You can see how the sun is amongst the smallest. And then the three stars in the belt, again, the sun is very, very much smaller than the three of them.
Hi, Brian. I hate to interrupt, but I
just got a few more slides.
Okay.
Sorry, I've been watching the clock too, trying to speed up here a little bit. Now, if you'd like to know more information about our club, we are the Niagara Centre of the Royal Astronomical Society of Canada. Our website is astronomyniagara.com. We are also on Facebook. You can follow us there. And just a couple, and this was the latest slide, I believe, by Philip Downey. Sorry, no, back in 2019. There's Orion's Nebula and a couple more. We post pictures nicely. If you want to come to our meetings, you are more than welcome once they start up again. We have all walks of life, from kids to older people. We have people who have built their own telescopes or have some pretty crazy rigs for taking photography. And it's a very gregarious group. We like newcomers so that we can get them hooked on our hobby. This is our meeting at the LaMarche Room in Niagara Falls. We also have several events when we can have them of star nights where we bring out the big telescopes and everybody can come and take a look through them. And on occasions we do lectures at libraries or museums or anywhere else that at the museum. Again, just get an email off to them. And this was one of the last nights that we did have that was successful. And the last slide I've got, just because we're going to get asked about, I want to buy a telescope, and I tell people not to. Telescopes are very strange. Not all telescopes work with all people. We have a loanerscope program at the club, so if you join the club, you can borrow several different ones and figure out which one you actually do like to use. We also have two observatories, one for photography and one for observation, so you don't even need to buy anything. And as I tried to show you, you can start astronomy with absolutely no money at all. However, if you have a pair of eyes, you're away to the races. However, if you have lots of money and want to start spending money, you can buy telescopes. Here's one for about $3,000. This one jumps up to about 46,000, and we're around 63,000. I have seen telescopes where the mirror itself was worth $2 million, and this was put up by a private individual. So it's the cheapest or the most expensive hobby you can have. If you really want to ignore all of my advice and want to go buy a telescope, I would recommend going to Canada Wide Astronomy Buy Sell. It's kind of like a YouTube for Canadian astronomers, and they will put all of the stuff they want to sell up here. You will find a good telescope here for the same money that you might find at a box store, which you're going to get a piece of junk that's going to really hurt you as far as astronomy goes. For the same money, you can buy a used scope. The nice thing about a used scope is it often comes with extras. So a lot of people don't realize you buy a telescope, now you got to buy eyepieces, you have to buy a finder, and on and on. When you buy a used scope, oftentimes you'll get extras with it and you'll get some help from the person selling the scope. This one was $500, and that's what you get for $500. That's a good entry level, intermediate, and pretty much you can use this all the way through. It's quite a phenomenal scope and around $500. So with that, I'm going to close up. And if you have any questions, please ask away.
So if you have any questions, there's a Q&A button at the bottom, and you can type in your questions there. If you're on Facebook Live, then you can just enter your questions into the comments and I'll monitor those.
I must have put everybody to sleep then. That was a bit of an experience trying to do that in 45 minutes.
Any questions? Let me just check Facebook. Oh, let's see. We have a question. If a sun flare were to come close to us, what kind of storm would it produce?
Well, it depends on the size of the flare. We've had some pretty major ones, and some of the actual particulate matter has reached Earth from the flare itself. The explosions off of the sun are quite violent, and it really depends on a whole bunch of other things. But if you go to spaceweather.com and keep an eye on the little pictures, they will tell you basically what's going on. And if we get some nice flares, we might get some nice auroras, and using just a cell phone, you can take some pretty impressive pictures.
Another question, how many galaxies are in the universe?
Countless. There's, I don't know anybody that would make an estimated guess, because it would be based on math that could be quite faulty. So that's a really difficult question to answer.
Here's a good one. What is the darkest area of sky in the Niagara area? So where can we go in Niagara to see the most things?
Well, it depends on how far away you want to drive. I go, like, I'm just south of Five Corners here. I'll head off to Fireman's Park. I like going down to Niagara on the Lake, finding the far side of the Fort George over by the Octagonal is really nice. There's a couple of parks that are very well suited. There's one that faces north very nicely that we took a bunch of pictures of the comet from. If you don't mind driving a little further, somewhere between Beamsville and Grimsby is very good. The darkest sky itself is about Wellandport area. We have our observatories out in the Wellandport area because of its darkness. So if you don't mind driving for a period of time, Wellandport is very nice and dark. You can go online and Google dark skies in Niagara, and it'll actually come up with a map and show you where some of the darkest skies are.
Okay, and somebody is wondering where they can get the email links that you were talking about. Is there a way that they can get those from you, an email or a website?
Well, I can send them off to the museum in an email if you want to do that, or you can send an email through our website, Astronomy Niagara, and they'll send it off to me and then I can answer directly.
Okay, and I think that's it for our questions. Any last questions before we wrap it up? Just checking Facebook for any last questions. I think that's it. Last call for questions. Okay, so I think we'll wrap it up there. And so I'd like to thank you, Brian, for your presentation. It was very informative and very thorough, but I know it's the universe is a huge thing and there's so much to learn. So we look forward to seeing you again and hearing more in a week from tonight for the second part of Astronomy 101. So thank you again. And thank you everybody for attending, and have a good night, and everybody stay safe.